If you clicked on this video, welcome to the machine learning community. Moving on,
the topics that I'll cover today: the basic definitions of machine learning, then why do we require machine learning and why not machine learning, and the key components that are required in the machine learning, types of machine learning, and also the challenges in the machine learning. So let us start with the definitions. When most people hear machine learning, they picture a robot, a dependable butler, or a deadly terminator depending on who you ask. Definition: what do you mean by machine learning, or what is machine learning? Machine learning is about training or teaching computers or machines to learn from an information that you give. It combines computer science and creative problem solving to build programs that improve with data. So here basically we have to feed the data and make the machine learn from those data. Machine learning is like training a student. We give them data and they learn to perform tasks or make decisions on their own. It's a subfield of artificial intelligence that allows computers to improve without explicit programming. For example, imagine AI is like building a car. Machine learning would be like designing an engine that learns and adapts to improve performance over time. For example, imagine you're training a new employee to identify different types of flowers. You show them pictures and give them feedback. Machine learning is similar. We feed the data into the algorithm and it learns to recognize the patterns. The more the data it sees, the better it gets at identifying new flowers. But there are two terms to remember. Those are underfitting and overfitting. Those two terms we'll learn in the coming session. So let's continue to the next slide. The key components in the machine learning. There are three key components in machine learning. Those are data, algorithms, models. Let's start with the data. This is the fuel for machine learning. We need lots of data to train the algorithms effectively so that they perform better. Now let us learn about algorithms. These are the mathematical formulas that learn from the data. There are many different algorithms for different tasks. Now let us learn more about models. What are models? Imagine model is like a machine. Once they are trained, the algorithm becomes a model that can be used to make predictions or decisions on new data. So let us see why we require machine learning, or what is the use of machine learning. So here we have 4 points to observe. Those are automation, data-driven decisions, improved accuracy and efficiency, and personalization. So let us start with the first one, that is automation. Machine learning excels at automating repetitive tasks. Algorithm can be trained to handle tasks that are time-consuming for humans, freeing us from more complex work. For example, machine learning can automatically filter spam emails or recommend products you might be interested in. Data-driven decision. Machine learning allows us to analyze massive amounts of data to identify patterns and trends that humans might miss. This data-driven approach can lead to better decision-making in various fields, from finance to medicine. Improved accuracy and efficiency. Over time, machine learning models can continuously learn and improve their performance. This can lead to increased accuracy in tasks like spam filtering or fraud detection. Additionally, automation through machine learning can streamline processes and improve efficiency. Personalization. Machine learning algorithms can be used to personalize experiences for users. For example, recommendation systems on streaming services or online stores use machine learning to suggest content or products tailored to your individual preferences. Let us see why not machine learning. Again, we have 4 points to consider. First one is bad data, bad results, and followed by explainability issues. Then job displacement and also ethical concerns. Let us see the points one by one. Bad data, bad results. Machine learning relies heavily on data for training. If the data is poor quality or biased, the ML model itself can become biased or inaccurate. Imagine a spam filter trained on poorly labeled emails. It might end up marking important messages as spam. This could get us in a lot of trouble. Then let us come to explainability issues. Sometimes it's like a black box. You know the ML model makes a decision, but it's hard to understand exactly why. This lack of explanation can be a problem in situations where fairness and transparency are crucial. Job displacement. As machine learning automates more tasks, some jobs might be lost, while new opportunities will likely arise in retraining and adapting the workforce. Ethical concerns. Data privacy is a big one. Machine learning often requires a lot of data, and how the data is collected and used raises ethical concerns. Additionally, there's a risk of AI misuse in certain scenarios. In these 4 points, there are 2 points that come up very highly. Those are explainability issues and job displacement. In the explainability issues, sometimes the scientists are not able to give a reason why the model is working so perfectly. And the second one, as you all know, there's a fear that people specifically the IT people might lose their job because of AI. So let us see an application for the understanding of how a machine learning works. Let's take a common application of machine learning: recommendation systems. Imagine you are scrolling through a streaming service and see movie recommendations you might enjoy. This is powered by machine learning algorithms working behind the scenes. Here's how it breaks down. There are 3 points to consider here. Those are data collection, model training, and making recommendation systems. Data collection. The system gathers information about your viewing habits, movies you have watched, ratings you have provided, and maybe even how long you have watched a particular movie before stopping. Model training. This data is used to train a machine learning model. The model analyzes viewing patterns of many users to identify correlations. For instance, it might learn that people who enjoyed movie A also tend to like movie B. Making recommendations. Based on your watch history, the model predicts movies you might be interested in. It considers the movies you have watched, what other users with similar tastes watched, and other factors. So let us see what are the types of machine learning. So there are many types of machine learning to include, but majorly there are 3 types of machine learning. Those are supervised machine learning, unsupervised machine learning, and reinforcement machine learning. So let us see few types of machine learning. First one is supervised machine learning. In supervised machine learning, the algorithm learns from a dataset that includes both input data and labeled outputs. The algorithm learns to map the input data to the desired output, enabling it to make predictions for new unseen data. For example, spam filtering in email uses supervised learning. The algorithm is trained on a massive dataset of emails labeled as spam or not spam. By analyzing features like keywords and sender information, the model learns to identify future spam emails. Supervised learning. The model learns to identify future spam emails. Unsupervised machine learning. In unsupervised machine learning, the algorithm analyzes unlabeled data, meaning the data that doesn't have predefined categories. The goal is to uncover hidden patterns or structures within the data itself. Reinforcement learning. In reinforcement learning, the algorithm interacts with an environment and learns through trial and error. It receives awards for desired actions and penalties for undesired actions. This feedback loop always allows the algorithm to improve its performance over time. For example, self-driving cars use reinforcement learning. The car's AI constantly observes its surroundings and takes actions. It receives positive reinforcement when it navigates safely and avoids collision, enabling it to learn optimal driving strategies.
There are several challenges that occur in machine learning, but the very basic one is the data quality and quantity. In that, there are 3 more things to add, that is insufficient data, noisy or incorrect data, and also data imbalance. Let us see one by one. Insufficient data in the sense ML models require vast amounts of data to generalize well. Lack of enough data can lead to poor performance and overfitting. Noisy or inaccurate data in the sense if data contains errors, outliers or inconsistencies, the model may learn incorrect patterns and make inaccurate predictions. Lastly, data imbalance in the sense in cases where some classes are underrepresented. For example, fraud detection, models can become biased towards more frequent classes, leading to poor results for underrepresented ones. Moving on to the next challenge, that is feature engineering. In feature engineering, there are 2 other terms that add up to it. Those are relevance of features and dimensionality reduction. Extracting meaningful features that contribute to predictive power is crucial but often challenging. Dimensionality reduction in the sense handling a large number of features or curves of dimensionality can complicate training and affect model accuracy. Let us move on to the very important challenge that occur in machine learning, that is overfitting and underfitting. Overfitting in the sense when a model is too complex and captures noise in the training data, it performs well on training data but poorly on unseen data. When we come to underfitting, if the model is too simple, it may not capture underlying patterns in the data, leading to poor performance. Also, there are numerous challenges that it can take up, such as ethical concerns and biases, and also security reason where data can be poisoned to get very different prediction as well. So these are the challenges that you have to look up to when you're trying to create a machine learning model or any projects. And that's it for today, guys. In the coming session, we will be learning more about the models and as well as the projects surrounding them. As you have come to the end of the video, please make sure to subscribe to this channel and also share this video among your friends so that even they can get the knowledge of machine learning, and make sure to comment on this video if you have any doubts. Thank you.